Did you know that current as small as 100 milliamps is enough to kill you, and that voltage as high as 5,000 volts in certain situations will not even tickle you? Stick around and find out the main difference between current and voltage. What's up everyone, I'm Joseph and welcome to STEM in Focus. If you're new to the channel, please consider subscribing and hit the bell for notifications so you never miss a video. So to begin with, we'll start by explaining what current is. First, consider the structure of an atom as proposed by Niels Bohr. The atom consists of a positively charged nucleus surrounded by electrons. The nucleus consists of protons and neutrons. Now, an electrostatic force known as Coulomb's force exists between the protons in the nucleus and the electrons. According to this model, electrons move in concentric orbits around the nucleus, with the closest ones having the strongest of forces. This is based on Coulomb's law of attraction, which states that the force between two charged particles is inversely proportional to the distance between these particles, meaning electrons found on the outermost orbit or shell have the least force of attraction with the nucleus and would require less energy to make the electron free from its orbit. For example, the most used metal for wires, copper, has 29 electrons with 1 electron in its outermost shell, and it would require very little energy to set these electrons free from orbit. It is important for electrons to be free from orbit to create the current effect. Moving on from the atomic scale, let us consider a strip of copper wire. Now, a mole of copper could contain about 10 to the power 23 copper atoms, meaning there are so many electrons in a copper strip. The outermost electrons of these atoms receive thermal energy from the surroundings and escape from the orbit. The net motion of electrons in the copper wire strip is zero, since the direction of the individual electrons are random and cancel out. When the wire is connected with a cell and a ball, the electrons move to the positive terminal of the cell and away from the negative terminal of the cell. So the rate of flow of these electrons is what we term as current. Now let's move on to define what voltage is. Take a ball of mass m. The potential energy of the ball at a particular height is m times g times h, where g is gravity. Moving the ball higher increases its potential energy and therefore increases the force on impact when it hits the ground. In a battery cell, the internal chemical action accumulates positive charges on the positive terminal and negative charges on the negative terminal. This split in polarity of charges creates a potential difference across the cell. If a copper wire is connected across the terminals of the battery, electrons will have enough energy to overcome atomic collisions and repulsions and move to the positive terminal. In moving 1 coulomb of charge between the 2 points, if 1 joule of energy is exchanged, we can say that a potential difference of 1 volt exists between the 2 points. In other words, voltage is the energy required to move charges between 2 points. Now, obviously, current and voltage are related in some sense. Voltage is the energy required to move charges, and then current is the flow of these charges. So mathematically, these are related by the Ohm's law, which is V equals I times R. Meaning, when you have more voltage, it means you're going to have more current. I hope you enjoyed this video. Click the like button if you did, and please consider subscribing. Thank you very much for watching this video, and I'll see you in the next.